All right, whether magma cools below ground to form intrusive igneous rocks, known as plutonic igneous rocks, or lava cools on the surface as extrusive igneous rocks or volcanic igneous rocks, it's more rocks. But when that lava is coming up and out, or some other things associated with volcanism at the surface, what are some of those hazards? Let's talk about it. You probably can't talk about volcanoes without first talking about the Ring of Fire. Oh my goodness. So the Ring of Fire is an area around the Pacific Ocean, mostly around the Pacific Plate, but also the Nazca Plate as well. Most volcanoes in general are near plate boundaries. Not all, but most. Every once in a while you get a weird one in the middle of nowhere, in the middle of a plate, called a hotspot, such as Hawaii. It's in the middle of the Pacific Plate that's known as a hotspot. However, most volcanoes are going to be right along plate boundaries. This highlighted pink thing is the Ring of Fire. And if you notice, the boundaries also are these boundaries with little triangles on them. That's the typical symbol you use for the convergent boundary. Convergent boundaries also contain the most active volcanoes. They can be located at divergent boundaries, but convergent boundaries, not only going to get the most earthquakes, but also the most volcanoes. On top of that, all around the Pacific Plate and Nazca Plate, known as the Ring of Fire, it's a convergent boundary, so a lot of volcanoes in general, but what's crazy is that 2/3 of all the world's active volcanoes are within this Ring of Fire. So all the active volcanoes on Earth having erupted within the last number of thousands of years, considered an active volcano, 2/3 of them around the again, the Ring of Fire around the Pacific Ocean, Pacific Plate, Nazca Plate. It's a very nasty place to live if you live anywhere near the Ring of Fire, which, look, cuts right through the United States. This is Mount Rainier in St. Helens in Washington, Lassen Volcano in Northern California. So some major volcanoes, all in the Ring of Fire. So what is a volcano? Well, it's simply put, a vent through which lava or sometimes solid rock, ash, and gases erupt from Earth's crust to the surface. Can be explosive or non-explosive. So not just lava comes out of a volcano. Sometimes it's other stuff. Remember the difference between lava versus magma? Lava, molten rock that reaches Earth's surface. Magma is molten rock below Earth's surface. So we're talking mostly about surface processes when this material gets to the surface and what hazards are associated with that. So when people think volcanoes, they think lava. There's actually two types of lava. The first type of lava is called a'a. It has a rough, jagged, craggly surface. That's this first image up here. It has a higher viscosity, so it's sticky, kind of slower moving. How fast or how slow? About 10 feet per hour. So that's not very fast at all. So as a'a flow is moving, it moves very slow. Here comes the flow. Oh, I'm out of the way. You can't really stop lava, so if it's coming towards your house, if you live, for instance, like in Hawaii or something like that, well, there's not much you can do, but it does move very slow. So lava is not much of a human threat. You can get out of the way of it. So here's a very slow-moving flow on Hawaii. You can see as it moves and it creeps in. There's really nothing you can do but just hope it doesn't hit your house. Looks like there's a house here, and not so lucky. Again, just very slow moving. It's kind of, it's glowing red because it's hot, but it's just very slow moving, and it's not much you can do. Again, not much you can do. All right, these look like very fancy. This looks like a very fancy house. Not much you can do. So the other type of lava is called pahoehoe. That's a fun word, pahoehoe. So pahoehoe is very smooth, ropey, like lava. You can see it almost looks like folded up sheets, or this is the ropey structure. It looks like thin ropes kind of braided together, like strings, ropes braided together. It has a very low viscosity, so it's faster moving. How fast? About 6 miles per hour, which is, about a good fast jog. So most people could get out of the way. You see it coming, you jog out of the way. So again, lava is not really that big of a threat to humans. All right. So when we think volcanoes, again, most people think lava. Really not that much of a threat. To property, of course, you can't really stop lava. If it's coming towards your house, it's coming towards your house. All you can do is just hope and wish it stops or somehow kind of moves its course. But in general, again, lava, not very dangerous to life, but it is to property structure. So it does cause a lot of property damage. Volcanic gases are another thing that come out of eruptions. These are given out, but this is crazy, it's given off by active volcanoes or even dormant volcanoes. Even though it might not be erupting lava, volcanic gases could be coming out. The principal components of volcanic gases are, a lot of it's water. Remember that water that mixes in with the molten material to form some helps to facilitate melting of magma. So water content, as well as carbon dioxide content, but then also some nasty stuff like sulfur dioxide and hydrogen sulfide. Each of these two could potentially create poisonous gas among some other things. So lava, not that serious of a hazard to humans, but volcanic gases, that's actually the second greatest threat to human life during an eruption. Sometimes, again, they come with volcanoes that are erupting. Sometimes the volcano doesn't even have to erupt. It's just gases leaking out. So you can see this volcano is not erupting, but you have volcanic gases coming out of here. Sometimes they come out of the side of a mountain. Again, they can be poisonous. So this person has to wear a suit in order to protect themselves and special breathing apparatus so they don't poison themselves. Watch out for volcanic gases. Again, second greatest threat. So what is the number one greatest threat, you say? Something called a pyroclastic flow. Before I give you information on pyroclastic flow, let me give you another piece of the super secret code. It's the number 8. You got me? 8. One more time, number 8. So, pyroclastic flows. Pyroclastic flows are pyroclasts. Clasts are pieces of rock. Pyro exploded out. So, small pieces of rock, or sometimes large pieces of rock, exploded out of a volcano that flow downhill very rapidly, buoyed, floating on top of, floating and buoyed up by heat and floating on poisonous volcanic gases. So sometimes when volcanoes erupt, they create these pyroclastic flows. A bunch of debris, exploded out material from small little pieces to bigger pieces that are super hot, 1,000 degrees Celsius, that flow rapidly downhill, kind of floating on a hot cushion of poison gas, flowing rapidly downhill. If you're standing there when a pyroclastic flow comes in, you're going to be burnt, you're going to be poisoned, and you're going to be sliced and smushed and crashed and get smushed with rocks, some small pieces, some larger pieces. Not a fun way to go. So you're cut, crushed, burnt, and poisoned. Good times. So this is the greatest threat to human life during an eruption. But again, pyroclastic flows, they do not occur in all eruptions. You need more of an explosive eruption, so you need more explosive magma content, andesitic or andesitic leaking into rhyolitic, because of your basaltic, low viscosity, runny eruptions don't have the explosive power to do something like this. Here's a video showing you an example of pyroclastic flows. Again, if you're in the way, there's not much you can do. They move at over 100 plus miles an hour. So they're fast, they're hot. If you're too close, there's no getting out of the way of this one. And here's another image. The material that make up the pyroclasts in this cloud of material, this pyroclastic flow that moves downhill, range again from small little specks of dust to large big boulders the size of houses. Just all rapidly flows downhill, kind of floating essentially on a cushion of hot poison gas. Not good. It was one of these pyroclastic flows that moved in and covered the ancient city of Pompeii in the year 79 CE Common Era. So just under 2,000 years ago. So the city of Pompeii was at the kind of base of Mount Vesuvius. Mount Vesuvius erupted, pyroclastic flow came in, killed, covered the area. Again, pyroclastic flow, greatest threat to human life. So much material that the town of Pompeii was buried, covered, and forgotten for almost 2,000 years until it was uncovered, I believe, in the early 1900s. And so what some archaeologists were doing, they were starting to dig, and every once in a while they would kind of put their shovel, or they're using these long poles to kind of poke through the material to see what was down below before they dug down. And these poles and their shovels would all of a sudden dig, and all of a sudden open up to this big cavity, this big open cavity about the size of a body. And it would happen again. It would happen again. What they figured out is that these cavities were actually where people were when this volcano erupted. The material covered them, killed them. As their bodies decayed away, it left behind this cavity in the shape of their bodies. So what was left in these kind of body-shaped little holes was nothing more than their bones that were still there. But again, the shape of their body, however they were, right before they died, that's what these shapes were. So what they started doing when they uncovered these is would dump cement or plaster into these cavities, fill them in, kind of dig around it, and these molds of people were kind of left behind. Kind of, very, very sad and kind of scary to think about, and kind of creepy in a sense. But it ranged from adults to kids to animals. They actually brought some of these around on tour to the Arizona Science Center a couple of years ago, so you could actually see these. I won't show any more. If you are interested, you can check out the city of Pompeii, Mount Vesuvius, Google this stuff, but you can find these. If you go to this area, these casts are there where they lie. Families just there, people running in the streets. However they were when this pyroclastic flow hit them is how they are for eternity, I guess. Scary to think about. All right. Well, when we come back, we'll talk about types of volcanoes. We talked about igneous rocks. We talked about hazards associated with volcanoes. Well, what types of volcanoes create these hazards? What types of volcanoes can aid in the creation of some of these igneous rocks? We'll talk about that in just a minute. See you then.